All right, question 3 is a interesting little parametric equation. We've got position of x equation, position of y equation, and we would like to know during what time is this particle at rest. So what you need to understand for this to be at rest is you want it to not be changing in the x direction and not be changing in the y direction. So that change is going to come from the derivatives. So if we find x prime of t, a couple power rules. So this is the derivative of x, which of course represents the rate of change of x for any given time. And I would like to know when this guy is at rest. So I'm going to set him equal to 0, and we could factor out a GCF and see that it is at rest in the horizontal direction during 0 seconds and 4 seconds, where both of these equal 0. Okay, but just because it's at rest in the x direction doesn't mean it's also at rest in the y direction. So we also need to do the same thing for y. We can figure out how he is changing over time with his derivative. And if I want to know when it's at rest, I want to know when that is 0. And looks like we can do another GCF here. And a trinomial. And okay, so 6 doesn't equal 0. T minus 4 equals 0 at 4 seconds. And t plus 1 equals 0 at -1 second. So it's at rest at both the x direction and the y direction at 4 seconds. So if it's not moving in the x direction or the y direction, then he is completely at rest.